Hey everyone, happy Monday. This week we are going to focus on functions. It might be a good idea, just like I encouraged you last week, to take some notes on just, some of the definitions so that when I ask you to, solve problems using those definitions, you know what they mean. This week's a little bit different than last week. Last week, some of you guys used some apps to solve the equations. This week, unfortunately, the apps don't solve functions. So you're going to actually have to watch this video and watch me do the examples so that you can do the questions of the day and the assignments. Okay? So first we're going to start off with some of the definitions. The first definition is what a relation is. A relation, as a reminder, is any set of ordered pairs. Okay, this is what we learned, I think it was chapter 4. Okay, now you have a whole bunch of set of ordered pairs, that's a relation. Now, when a function is a set of ordered pairs, okay, but where all the x values are different, okay? So then you got the definition of a domain. Domain's all my x values, whereas, whereas the range is all the y values. Okay, so take a second, pause the video if you need to, and then copy down these few definitions. It won't kill you, and literally it will take you a minute or two. Okay, so then the questions that you're going to see today are going to be like the ones I show you below. So example 1 says state the domain and range for the following relation. So the domain, if they're all my x values, remember ordered pairs are x comma y, the domain is going to be all your x values. So all the first numbers in the ordered pairs. So remember, you put them in little squiggly brackets, and then you list them and you put commas in between them. So -3, comma -2, comma 0, and notice how there's multiple zeros, you only have to write that once. Whereas the range is the second number in all of the ordered pairs. So I got 3, comma 4, comma 5, comma 6. Okay. Now part B, or the second part of the question, says, do the ordered pairs represent a function? Well, remember the definition of function up above is a set of ordered pairs where all the x values are different. So let's look at the question. Is every one of my x values different from each other? No, I see a duplicate of zeros. So no, not a function. All x values are not different. Okay. Now, example 2, it gives you a function. So it says solve for the value of the function, and it gives you an equation f of x equals -2x plus 10, and it asks you to plug in 5 for x. So remember, you're going to use parentheses, plug in 5 for x, and then type that on into your calculator. So you're going to drop everything down. Where there's x, you're going to put parentheses, and the number 5 goes in those parentheses there. Okay. Once you have this cell set up, you can just type that right into your calculator, or you could just do mental math. -2 times 5 is -10. Drop down the plus 10, and then simplify -10 plus 10, which gives me a 0. So when I plugged 5 into the equation, my final answer is 0. Okay. Now, lastly, number 3. It says, which table represents a linear function? In order for it to be linear, the pattern needs, if I could spell again, pattern needs to be constant. Okay, so which means you have to be going up by the same amount on the x's, which in the first block I am, +1, +1, +1, but you also have to be going by, consistent, or by up by a constant number or down by a constant number for the y values. So in order to go from 1 to 3, you add 2. In order to go from 3 to 1, you subtract 2. And in order to go from 1 to 3, you add 2. So this is not linear because my pattern is not constant. Okay. Let's look at the second graph there. Let me change pen colors. My x's go down by 1, down by 1, down by 1. So the x's are constant. And the y's, I add 4, I add 2, I add 1. That is not constant. Okay, so let's check this last one. So I'm going to add 1, add 1, add 1. So my x's are constant in this last table. And notice here, I'm going to add 1 for all my y values, which makes the last table a linear function. Okay, guys? Hope that helps answer the 3 different types of questions you're going to see today, and I will talk to you later.